Hey there, you're tuned to the Poor Little Crows channel. Today we got our parts in, a whole lot of electrolytic capacitors, so we can actually get going on replacing some components. But we're going to focus on just this one board today, the Power Regulator Unit, PB-1079A. It's for the early model. And before we actually change any parts, I want to do a few checks, and we'll show you how to do that. We want to make sure that our marker generator frequencies work, our clarifier works, and then I want to get a few base measurements of the three output voltages that board outputs. There's the bias grid, the bias driver, and the 6-volt regulation supply, which goes to a bunch of other boards in this radio. So we're going to get those looked at, change some parts, and then we're going to measure those voltages again and get them dialed in. So stay tuned. Real quick before we get started and everything, I just want to give an update since our last video, part 4. That electrical contact cleaner worked so well on cleaning those two relays. I went ahead and cleaned the switches and the potentiometers and all the switches up here. I didn't do the power switch or the heater switch, and I didn't have to do like the loading or the plate because they're not potentiometers or switches. So got the front all cleaned up with the electrical contact cleaner, even up here, as well as the band switch underneath. All those different switches on that big old gang switch, those got cleaned up. And the difference is this is a lot easier to turn. This probably has the most difference. This is so smooth now. So use the same automotive electrical contact cleaner, and I just wanted to get that out of the way just in case it worked so well. So yeah, that was a small little update, but now let's get back into the purpose of this video. So this is the board we're going to be changing, the Power Regulator Unit. This board model happens to be PB-1079A, and your model may be different based on what model of FT-101 you have. So keep that in mind. I'll be using the PB-1079A. And before we pop this out and change components, I'm going to do a few more checks. I know we're probably getting tired of checks, but I just wanted to confirm that things are working before we change any component in here, just to make sure we don't break something, because it would be very hard to troubleshoot, once I replace a bunch of capacitors. Let's say one capacitor went out. That's going to, it would just make it harder to figure out when we start putting new parts in there that something broke. So this board, it handles the 6-volt regulation that supplies a whole bunch of these other boards. So that's pretty much why I'm starting with restoring this board first, is because the 6 volts that come from this and feed other boards kind of the key to having other things work properly. So I think. So handles the 6-volt regulation. It also handles the clarifier. So I'm going to confirm the clarifier works. It also handles the marker generator for the 25 kilohertz and 100 kilohertz. And also the bias voltage for the grid and the driver. So we're going to confirm, at least measure a couple voltages, or 3 voltages. The bias voltage for the grid that comes off pin 2 should be negative 60 volts, at least if I read the manual correctly. Pin 4 should be negative 20 volts, and pin 13 should be the 6 volts. So we're going to do 3 of those measurements, and then I'm going to show you on the back side of how we can, or where to probe. So we're looking at the underside of the unit now, and directly right here, this is the back side of where that card plugs in. So pin 1 is on this side, and then pin 18's over here. So what I'm going to do when I measure this, similar, because I don't know, I don't want to be around a bunch of voltage, so I'm just going to clip a lead on the appropriate pin and see what reading we get. There might be other places that you can probe. I'm not sure. I'm just going to go directly to the source. That might be the simplest for me. So we'll get 3 voltages reading from the appropriate pin on that backside. Also, this is the directions that I'm going off of. This is from the early manual. I did not find anything in the service manual regarding this particular board model, the PB1079A. I believe it showed the newer model, but not this model. So it talks about what voltages should be on these pins and describes in here what pins do what. So that is where I'm getting my information from. I got the radio turned on, power's on, the heater's off, noise blinker's off, attenuator's off, and the marker's off. And this is what we're going to test right now, the 100 kilohertz and the 25 kilohertz. I have the radio in tune. I don't know if that matters or not. I got the volume pretty high, RF gain pretty high. Nothing really matters over here as far as I know. But I do have the band switch down to the WWV, and the clarifier is off. And then up here we're switched to INT and IAC, which I don't think it matters. So what I want to test first is the 25 kilohertz marker. And let's see if we can find it. I think that's it. All right, just to test, let's see if changing a band matters. So it sounds like you have to be in the WWV, at least for that quick test. Doesn't matter with the mode though, but I'll stay in tune. So now let's see if we can find, and we can see here too that we're not quite lined up to 25, so probably we'll have to get that adjusted later on. We'll get it. We'll get that calibrated after we do our component changes. So we should hear another tone here soon. So the 25 one works. Let's try the 100. I think that, yeah, I mean, maybe. It's pretty far off. Yeah, so this is working. So I'm going to try to find a signal now and we can test our clarifier. Alright, so it sounds like I found like the FT-8 signal. Let's just turn the clarifier on and see if we can lose that. Oh yeah, you can hear it tuning in stuff. So really hard to tell probably, there's a lot of static. But I can tell that the clarifier was doing something, whether it was working properly or not. It's not tuned probably, but we're going to calibrate that later. But it is working. So now what's left is the 3 voltage checks that we're going to do. I have the power connected to the radio now, so the cord's plugged in. We have our multimeter set to DC voltage. We got our black lead connected to the chassis. And then we have our red lead connected to pin 13. So the back side of our power regulator unit, PB1079A. And all we're going to do here is see what our voltage is. It's supposed to be 6 volts. That's what it's supposed to be set to. So all we're going to do is turn the radio on. We're going to leave the heater off. This is the first time I measure this, so we'll see what happens. Oh, look at that, 6.1 volt. So, awesome. So a good base measurement. So next thing we're going to check are our bias voltages. So I'm going to turn this off, and I'm just going to let the capacitors discharge for a couple minutes, and then I'll move our red lead Okay, so the radio is still off, but plugged in. Again, negative lead to the chassis. And now we have this connected to pin 4. And what we're going to do is check for the bias voltage for that. It goes to the driver, which is supposed to be negative 20 volts. This is reading negative 0.31 millivolts with it off. Just going to turn the radio on and see what we get. So not too far off. Negative 19 volts. I'm not going to check transmit. When we transmit, it's supposed to go to negative 3.5 volts, but we're just checking receive right now. So a volt off, basically. All right, so I'm going to turn this off, let it discharge, and then we'll do one more voltage check for the bias voltage for the grid. Okay, so now we have the red lead connected to pin 2, because we're going to check for that negative 60 volt bias voltage for the grid. Black lead connected to the chassis again. And just to reiterate, I am waiting a good couple minutes or so, sometimes longer, as I do other things, just to let those capacitors discharge. I'm in no rush to swap that out to a different pin. There's a lot of little metal leads here to touch on accident, so just take your time, be safe, no rush. All right, so we're going to turn the radio on now and see what we get here for that grid circuit. A little high. So we'll call it 74 volts. So 16 volts too high. Okay, well, that's our last measurement. We will now get that board out and get to work. All right, so I got that board out, and I went ahead and just matched the capacitors up to what it was in the manual and wrote the capacitor number down, because when I take this out, I want to actually measure the capacitance on these and see if there actually had any leakage. Some other game plan options, I'll probably use some electrical contact cleaner on all these little trimmers. Just, it worked. That electrical contact cleaner seems to do such a good job. I'm going to go ahead and hit those anyway. And then I'll probably have this out, measure the resistors and these diodes just to make sure they're okay. And I might even replace these Mylar capacitors. So we'll see. But we're going to start with changing all these electrolytic capacitors first. And I got this little discharge tool, capacitor discharge tool now. So I'll probably just go ahead and, I don't know if there's any charge or anything. No light came on, but I'm going to check them anyway, just in case before I unsolder them. And I ordered all of these capacitors off of DigiKey. So I got some really good ones, 105 degrees Celsius rated. All the voltages are equivalent or higher. And I forget how many the hours were. I think most of them were 7,000 to 10,000 hours of life. So high quality ones. Got some extras even. So a whole lot of those. And then for the Mylar capacitors, I just got this off of Amazon. What's this say? Just a little bit better picture here. So 700 total, a bunch of different values. So a little good assortment. It doesn't come very, I've noticed some of these are all mixed. So you might want some sort of tool to measure what the capacitance is. And I got this thing for really cheap. It's called the LCR-T4. And all you have to do, let's just take one of these bigger ones. And you just put it in. There's numbers here. Let's get a better lighting. And I think you just put it in 1 and 2 or 1 and 3. And you just kind of clamp it in there. Hit the button. And then it tells you how much capacitance is in there. So this is what I'll be using to measure these at the end, just to see what, was it a good idea to replace them? Did they still have life? and just kind of go from there. I just like to know if replacing anything actually is going to have any effect or not. So that's my plan. Um, so I'm going to start unsoldering those one at a time. I'm going to start here, for example, unsolder this, put the new one in, and one at a time, just so I don't, put something in the wrong way. And before I even get started, I'm gonna take some pictures to make sure I got the polarity all correct. So that way, if I get confused, I got a picture to go back to for reference, because the manual, you know, it's pretty washed out picture. It's really hard to see. I could tell a little bit, but I'm gonna take some photos just in case. I recommend the same. So gonna go unsolder and resolder, and then I'll be back when all of those are replaced. Well, it didn't take very long to get all these electrolytic capacitors off. I've got the new ones on now, much smaller. And I took some photos before, and then I compared and make sure the polarity was all matching. I tried using a solder wick. I never have very good luck using this stuff. Like, I don't know if this stuff is just not the right kind or what, but it never seems to like wick up the solder. And then I've also tried using this and never really had much luck with that. So how I got these in is I would just put the board down, kind of brace it, one hand, one other hand holding the iron, and I would hold on one of the capacitors and heat up one pad, and then wiggle a little bit, heat up the other one, and just slowly work it out. Be careful not, don't stress fracture it and break off the pin. If you break off the pin, then oh boy, that's really hard to get out, in my experience. Just because it would just heat up and yeah, don't break a pin. So carefully heat up one pad and the other pad, and just slowly work its way out. Don't have to like wiggle hard. Just heat it up and gently coax it out. So I got some measurements. I wasn't able to use this meter that I showed you before. The leads on these old capacitors are just too small. It wouldn't fit. So I used my other LCR meter and just these alligator clips. And I got some base measurements of, what I took off and what I put on. I know this is probably hard to see, but this is the early model manual. And what I did was I found the board, printed board PB1079A, and then there's a section for capacitors. It has dipped mica capacitors, electrolytic capacitors, which we just replaced, and 2 ceramic disc capacitors. So apparently these are also dipped mica, at least according to that part list, and not mylar. And they're rated for 500 volts, supposedly. So I am not going to replace these. The only thing I'm replacing capacitor-wise are these electrolytics. So what I'm going to do now is just test these diodes, just confirm those are okay, maybe spot check some of these resistors, and then go from there. But yeah, so reference the manual. I know these look like mylar, but apparently they're not. I don't know, but I'm going to follow the manual. And since they're not completely destroyed, they seem to be working, I'm not going to touch them. I got the card put back in. Terrible lighting, I know. I got the sun coming in the window right now. But I got the card back in. I sprayed electrical contact cleaner on there's 3 trimmers here, and there's one more down here. And then I also sprayed it on the card pins, not inside the socket. It looked really good in there, but just on the pins, just the heck of it. Why not? So what I'm going to do now is we're going to plug it in, we're going to turn it on, make sure nothing explodes, and then we'll get our bias voltage set and the regulator, 6-volt regulator voltage set. So I'm going to get the cord plugged in and we'll see what happens here. Okay, now the cord's plugged in. Got my safety glasses on. I'm going to turn it on and fingers crossed it lives still. Here it goes. 3, 2, 1. Look at that. Very nice. Sweet. So I'm just going to let it, I don't know what you need to do with new capacitors, but I'm just going to let it sit for a minute. Get all energized and broken in, if that's a thing for capacitors. So just let it sit here for a little while, and then I'm going to turn it off and flip the radio on its side so we can get some measurements on the other voltages, but still have access to be able to access those trimmer pots in there if we have to make any adjustments. So, oh, while this is warming up, actually, our marker still works. That's the 25 kilohertz, the 100. Wow, you know, it sounds way stronger than it did before. Holy cow. Yeah, so maybe some improvement with those. It sounds a lot better than what it did before. Maybe it's just my ears, but it sounds nice. So that's a good sign. I'm not going to bother testing the clarifier because I don't have antenna hooked up right now, but I'm sure that's okay, and we'll tune that later. All right, I'm going to turn this off. Turn this back off, and then we're going to get the radio flipped around to do some measurements. Okay, I'm just going to show you what I have set up real quick. We have our multimeter, which we're going to set to DC voltage. Our black lead is just connected loosely into one of these holes in the chassis. And then we have our red lead connected to pin 13. It's really hard to see, but that's on the underside of that regulator unit board. So pin 13. And then on the other side here, what we're going to do, if we have to make any adjustment, if it's pretty far off 6 volts, what we're going to do is this VR3 says volt above it, and then there's a frequency adjust one, and then the bias voltage. We're going to focus on this one. So if we have to adjust, that's what I'll be spinning. Okay, so the radio's all plugged in, power cord still plugged in, check. The heater's off. We're just going to turn the radio on. Well, first let's turn our DC voltage. Let's turn that on. Okay, radio's on. We're at 6.10, 6.09. I'm going to turn it and just see how touchy it is and see if we can get closer to 6 volts. But that's probably really good enough. But I'm going to just see if we can do any better. Just for the heck of it, why not? And using an insulated tool, don't use metal. I don't know if there's voltage on this or not, so I'm going to be careful. Alright, let's see what happens. Oh, that's so close. If this thing will even fit in here. That's a pretty stiff. Oh, okay. Now we want to go the other way. Man, I don't know how much closer we can get. This is, you barely move this thing and it goes all over. Ooh, look at that. On the money. Okay. That's all we got to do for that. 6 volt regulator voltage is set. So now I'm going to turn the radio off. And I'm going to move now our lead, and we're going to check the bias voltage for our grid, which is going to be pin 2. But I'm going to let the capacitors discharge for a little bit first. Slow and steady, nice and safe. Okay, another demo. Pin 2 connected to the chassis. And then on this side, move the light over. For these next two measurements, for the bias grid voltage and the bias voltage for the driver, we're going to want to be turning, what is this called? This is going to be VR2, it looks like. VR2, which is this one, this big one here. That's what I'll be spinning, if we have to make any adjustment, that is. Okay, so this is supposed to be at negative 60 volts. Again, heater's off. We're just going to turn the power on. It's at negative 75.2. So adjusting this, I think, is also gonna adjust our negative 20 voltage for our driver, which when we measured it last time, it was like at negative 19. So we'll see how close we can get this to 60 and keep the other one close to 20. So let's see what happens when we turn this. I'm not sure which way yet. Again, using an insulated tool. Alright, going the right way it looks like. See how close we can get that. See, now I gotta turn the other way just a hair. Oh. There we go, negative 60. So we'll see how close now our bias driver voltage is. Yeah, because looking at the schematic here, they both will affect each other. So we will see. One thing I forgot to mention was before I put that card in, I did check the resistors. I did a few spot checks. The resistors, they seemed okay, and I checked 4 diodes, and they also seemed okay. So I think component-wise we're all right. That was a huge jump in voltage down, or up, I guess. So I'll let this discharge for a little bit, and then we're gonna go measure pin 4, which will be our negative 20 voltage, and we'll see how close we are to that now. All right, we're connected to pin 4 now. Same setup as before. We'll be turning the same knob as before. Here we go, power on. Wow, not bad. Sweet, it hardly had any adjustment to this. So the driver voltage really didn't go down much. Let me look at my notes real quick. What did we have before? We had negative 19 volts. It went down a few millivolts, but our grid voltage went down to 60, and it was before 75. So I don't know what we could do for that. The only difference would probably be, tracing it down to this circuit, and maybe one of these 10K resistors is too much, or a 4.7K. It's really hard to read this, but I think that's good. I mean, I don't know how else we can change that. So I'm gonna leave it, call that as good as it's gonna get. And if we have to adjust anything later for some other symptom, we'll come back and relook at this. So yeah, good deal. Well, that concludes today's video. We got the Power Regulator Unit PB-1079A board, this one here, restored as far as we can go at the moment. Things are working, and so now I think the next thing to do is to work on one of these boards, so stay tuned for that video. I appreciate you guys watching. If you are, hope you're learning. I'm definitely learning, so I'll catch you in the next video. Signing off from the Portable Crows channel, 73.
I'm now a radio man. You can bet your boots he knows his stuff.